Okay, hello, this is Mrs. Clausing, and I am going to do the Algebra 2 Unit 5 Day 5 video. In this video, or in these notes, we're going to learn about solving radical equations algebraically, and then we'll talk about how to do it graphically. So this should be pretty quick. Up till today in this unit, remember we've talked about last class, we talked about adding and subtracting radicals by with variables. The class before that was just adding and subtracting radicals without variables. At the beginning of this unit, we talked about multiplying and dividing radicals with and without variables. Okay, so today we're going to talk about solving radical equations algebraically and graphically. Alright, so let's just start this first one. A couple of rules you can kind of think of when you're doing these are kind of related to is when we talked about absolute value back, this was 2 units ago or so. We talked about how we had to get it clean. We had to get those absolute value bars clean before we could actually solve anything. Similar concept we're going to use today when we're solving radical equations. Okay, so keep in mind you have to get it clean. Okay, kind of the same concept. All right, so let's do A here. We have this 2 that's hanging out outside my radical sign, so I need to move that 2 over. So to move the 2 over, I'm going to divide both sides by 2, because right now it's 2 times the radical, so the opposite of multiplying is dividing, so I'm going to divide both sides by 2. My 2's on the left will cancel and leaves me with the square root of x plus 5 equals 8 divided by 2 is 4. Okay? Then I'm going to, now it's clean, I don't have anything hanging outside my radical. So to get rid of the radical, I'm going to do the opposite. It's currently a square root. The opposite of taking the square root of something is squaring it. So I'm going to square both sides. When I do to one side, I have to do to the other side. So I'm squaring to get rid of my radical. Okay, so my radical will cancel with the square and leave me with just my x plus 5. And then on the right side, I have 4 squared, which is 16. Okay? So now my x plus 5 is free from the radical, so now I can just solve for x. So I'm going to minus 5 from both sides, and I get x equals 11. And that's my answer. Okay? So pretty simple, just got to get it clean, and then once we're clean, and the radicand is free, per se, so my x plus 5, remember, is my radicand. Once it's free, I can just solve for x. Alright, so let's go on to B. B has a second step to it. Again, we're just getting it clean, so I got to move this 15 away, and I have to move the 3 away from this radical. So I'm going to move my 15 first, so I'm going to minus 15. What I do to one side, I have to do to both sides. On the left side, my 15 cancels and leaves me with 3 cube root. Don't drop that index of 4x. It's getting a little funky. 4x plus 1. Alright, and then on the left side I have 16 minus 15, which is just 1. Alright, I gotta move that 3 over, so I'm going to divide by 3, because currently it's saying 3 times the cube root, so the opposite of multiplying is dividing. So I'm going to divide. What I do to one side, I have to do the other. On the left side, my 3's will cancel and leave me with just the cube root of 4x plus 1 equals 1/3. Alright, so now my radical is clean. So now I want to try and get my radicand free. To get it free, remember I'm doing the opposite of whatever my index is. So if I'm taking the cube root, the opposite of that is cubing. So I'm going to cube both sides. Okay. So then my cube root, or my radical, cancels with the cube on the left and leaves me with a freed radicand of 4x plus 1 equals 1/3 cubed. Okay, so this is going to get a little bit messy, but whenever I'm cubing outside parentheses, remember we talked about this last class, what I'm doing is I'm distributing that 3 to each piece inside. So I'm going to distribute the 3 to the 1, so I have 1 cubed. Do it with different colors so you can see. So I have 1 cubed, which is just 1. And then 3, I'm distributing it to the exponent, not the 3 in the denominator. So 3 cubed is 27. Get my board to work for me. Okay. Alright, so now my radicand's free. Now I just need to solve for x. Again, this is going to get a little bit messy, but just bear with me. And I'm going to come down a little bit into this D section because I'm kind of running out of space. But bear with me. So 4x plus 1 equals 1. Actually, I'll just move this over here. So we'll just move this up here so we have space. So we have 4x. Just rewriting it. I'm not changing anything. 4x plus 1 equals 1 over 27. Okay, so now my radican's free. So I'm ready to actually solve for x. So first I'm going to move my 1 over. So I'm going to subtract 1. So I do one side after the other side. Leaves me with the 4x equals, my 1's on the left cancel, 127 minus 1. Okay, bear with me, we're going to get a little, it's going to look a little messy, but we'll use your calculator and we'll clean it up. So now I need to get this 4 away, so I'm going to divide both sides by 4. Remember, this whole 1/27 minus 1 is on my numerator, dividing by 4, the whole thing. So on the left, my 4's cancel, leaving me with an x. And then on the right side, I'm going to just put this in my calculator. Start with my numerator, and then I'll divide by 4. So I'm going to go to my calculator, and I'm putting in 1/27, and I'm going to put it in as a, this, put it in parentheses, just so I keep that 1/27. I want the 1 divided by 27 before I subtract the 1. So it's minus 1. So my numerator is negative 0.96 messy decimal, which is fine. I'm just going to leave it in there, not change anything. Now I'm going to divide it by its denominator, which is 4. Okay, and then I'm just going to math practice. So I go to math, and then number 1 is frac, so I push number 1, and then enter, and it gives me the fraction. Okay. So then I write down negative 13 over 50, and that is my answer. Okay. So you could have done this, and you could have changed your, got all like denominators and done it by hand, or like we did, we just typed it into that messy fraction all into our calculator. All right, so let's move on. So we're going to go to C. Before I forget, we are going to skip E. So you can go ahead and mark that out on your notes. So C. So on these first two, we only had one radical sign. But on this second one, we have two radical signs. We have a radical on one side of the equal sign, we have a radical on the other side of the equal sign. So rather than getting it clean, there's really no getting it clean at this point because I have two radicals on either side of the sign, either side of my equal sign. What I'm going to do first is just go ahead and get rid of my radicals. So I'm going to cube both sides. The reason I'm cubing is because I have an index of 3. I'm going to switch to I have an index of 3, so I'm going to cube both sides to get rid of that radical. Now, I have to cube this whole thing, including that 2. And so remember, going back to last class, this cube on the outside is going to distribute to every piece on the inside. So when I distribute it to the piece on the left, it gets rid of the radical, cancels with the cube, and leaves me with a freed radicand of x minus 5. And then on the right, I distribute my 3 to both pieces. So I got to distribute it to my 2. So 2 to the third is 2 to the third is 8. 2 times 2 is 4, times 2 is 8. And then the cube and the cube on the outside will cancel for this radical and leave me with a 7 minus x. Okay? Alright, so at this point, what I would do is I would distribute this 8 and get rid of these parentheses. So 8 times 7. If you don't remember what that is, remember you always just go to your calculator real quick. 8 times 7. So I just gave up. It's 56. How do you know that? But just want you to remember, calculator's handy tool. Alright, so 56, and then 8 times a negative x is a negative 8x equals, we still have x minus 5. Okay, so at this point, I'm going to combine like terms, trying to get all my x's on one side and all my constants on the other side. So I'm going to try and move, I want to get rid of this negative in front of my variable, so to get rid of it, I'm going to move it over to the left. So my negative 8x, I'm going to add 8x to both sides. And I line it up under its like term so that I don't accidentally combine it with a non-like term. And then my negative 8x and my 8x cancel on the right, leaves me just at 56. And then on the left, I have x plus 8x, which gives me a 9x, minus 5. And I need to get my x by itself. So now I need to move that 5 to the right. So it's a minus 5, so I'm going to add 5 to both sides. On the left, that cancels and leaves me with, I'll just come down here below e, I have 9x on the left, and then 56 plus 5 is 61. Okay. Now I still need to get x by itself, so I need to get that 9 away, so I'm going to divide by 9. What I do one side, I do both sides. My 9 cancels. On the left, it leaves me with an x, and then 61 divided by 9. I can leave it like that on the right. Okay. Alright. So, that is C. We have two radicals. Just to summarize, we have radicals on both sides of the equal sign. The easiest thing to do is get rid of your radicals first, and then solve from there. Okay? So, let's see. Let's do D next. Alright. Alright, so D. Alright, so the first thing I'm going to do is try and get it clean. I only have one radical on one side of the equation, so I'm going to try and get this clean. So I'm going to move my 8 over first. And then I have, that leaves me with a negative 6 square root, because remember my index is 2 when I don't see it, so it's a square root. X minus 1 over 5. My 8's cancel on the left and leave me with a negative 12. Negative 4 minus 8 equals negative 12 on the right. Okay, now I need to get it clean, so I got to get that 6 over. So it's negative 6 times the square root, so the opposite of multiplying is dividing. So I'm going to divide both sides by a negative 6. Okay, my 6's cancel on the left and leave me with square root x minus 1 over 5 on the left and equals negative 12 divided by negative 6 is 2. Negative divided by negative is positive. 12 divided by 6 is 2. Okay? So remember we said when we did like example A or example B, we got it clean and then we need to actually get rid of our radical. So the index here on this radical on D is a 2. So I'm going to do the opposite of taking the square root and I'm going to square it. What I do to one side, I have to do to both sides. And my square and my radical cancel with each other on the left. I go a little bit below F to write this down. And now my radicand is free. X minus 1 over 5 equals 2 squared on the right, which is 4. Okay, so at this point, I'm just going to solve for x. Okay, so I have x minus 1 over 5 equals 4. So I'm going to cross multiply. Remember, 4 I can say is over 1. And I'm going to cross multiply, so 5 times 4 is 20 on the right, and 1 times x minus 1 is just x minus 1. Okay, so now I can solve for x, so I'm going to add 1 both sides. My 1's cancel on the left, and we move just an x, which is great. That's what I'm trying to get by itself. And 20 plus 1 is 21. Okay? Alright, so F, I'm going to let you do and bring that to a class next time. So I want you to do F, and we're going to move on, but F I want you to do is practice. And remember just a couple hints on F. We erase, choose different colors. So F, remember hint, when you have a power outside of parentheses, talked about this last class, you got to distribute it to everything inside the parentheses. You distribute it to their exponents. And remember, if we don't see an exponent, like on this X or on the 5, it is automatically a 1. So remember, we're distributing this 2/3 to the exponents on each of the terms inside the parentheses. Okay? Alright. So let's move on to the next page. Okay, so now we're going to just do some quick calculator tricks on how to solve this with your calculator. Turn to it what you need first. Okay, so let's do this first one. All I'm doing here when I'm using my calculator is I'm putting the right side, there's no math I have to do, I'm putting the right side into y1 and the left side of the equal sign, sorry, it's backwards, the left side into y1, right side into y2. It doesn't matter, you could have switched those and put the left side into y2 and the right side y1, it doesn't matter. Just put one side of the equal sign into one y and the other side into the other y. So we have, just typing this in so I got go to my equals, and I'm going to clear out what's in there, and then I have 2 square root of x plus 1, those parentheses, And then the other one, I have the square root of 2x minus 5. Okay, so now I'm going to graph it. And you'll notice that neither of these lines ever intersect. What we're looking for is our solution is where the two lines intersect. Okay? But kind of like when we had systems of equations and we were looking for, we had two different equations and we graphed them and we looked for where they intersect and that was our solution. Same thing here. I'm looking for where the two lines intersect and they don't intersect, so that means we have no solution. Okay? So the answer here is just no solution. Now, I'm not going to solve it out, but if you had solved this out algebraically, it would have given you that x equals -9 halves. So if you had solved it out like we had done back here where we used it algebraically on page 1, you would have gotten to x equals 9 halves. And you would have said, is that my solution? Well, you have to be really careful when you have radicals or equations with radicals because you can get what's called extraneous solutions, which means they are not real solutions. Okay? So if it's an extraneous solution, when you graph it, they do not cross. Another way to figure out if it's extraneous, which this is not a huge thing you're probably going to have to do very often, but you can check it by putting the x back into your original equation, and when you plug it in, both sides to match. If they do not match, then it's an extraneous solution. Does not count as a solution. Okay? So no solution for A. Alright, so again, two ways to find it. Either if you solve algebraically, what you really should be doing, which we didn't do on this front page, but what we could have done is plug in everywhere we got x, plug it back into the original equation and make sure that it is a valid equation. Okay? Or so you can either, when you solve algebraically, you plug it back in and see if it works, see if it's a valid equation, or you graph it, the lines don't cross, it's no solution. Okay? So two ways to figure out if you have an extraneous solution or not. Alright, so let's go on to B. Alright, so this one, again, when we're using, if you look back at the directions, it says using your calculator. So that means we're just graphing it. So we put one side of it by 1, one side of the side of it by 2, and we look for where they cross. Here, go to our y equals, clear out what's in there. We have 2, and remember we get the cube root. We have to go to math, and number 4 is a little cube root. So we want to select number 4, and that's x. And then we have 3, math, number 4, and we have x minus 2 under the radical, or that's our radical. And then we graph it. So remember, just like with systems of equations, we're looking for where they intersect. That's our solution. Or maybe they don't intersect. See, there they are. All right. So remember to find intersecting points. You can do that in the calculator as well. You can just roughly estimate it just by pushing your trace button, and you get the little cursor, and you just kind of go close. That would kind of get you close, but it's definitely not exact, right? Somewhere around 2 or 3-ish, where x equals 2 or 3 is where they cross. But I want the exact point, so I'm going to go to second calc. And number 5 is intersect, and I just push enter 3 times. Okay, so they intersect at 2.842, or x equals 2.842. So x equals 2.842, and I'll just draw a quick little graph. X-axis, y-axis, like 2 elongated pieces. So something like this. This is the point we're looking for. I just wrote my x and y backwards. Okay. Y-axis, x-axis. Okay, so where they intersect is our solution. Okay, so letter C. So similar to when we had absolute value. Remember when we had absolute value, we had to see if it was even possible. First we'd get it clean, and then we'd see if the problem was even possible. So let me just throw something up here real quick. Just a side example of when we had absolute value. We had, for example, if we had like 2 times absolute value, we'll make it a negative 2. Negative 2 times absolute value of x plus 1 equals 4. I had to get it clean first, so I divided both sides by a negative 2. My 2's canceled and left with absolute value of x plus 1 equals a negative 2, right? 4 divided by negative 2 is negative 2. So we got it clean, and remember we always had to see if it was even possible. Absolute value, remember, it always gives us a positive, and over here we have a negative, which is never ever possible. So this would be no solution. Okay. Same concept we're going to use here. Okay? Whenever you have an even index, so here, remember my index is a 2 if I don't see it. So if it's even, then think about it that this has to be positive. Similar, just relating it back to absolute value, and this is negative, which means this is never possible because we have a negative over here with a negative 6. The answer here is no solution. Now, this is only true, you would only get no solution like this if you have an even index, okay? If you don't have an even index, then it is possible and you would solve it. This is only if you have an even index, okay? Alright, so that's C, no solution. And then D, I'm going to let you do that by yourself and bring it to class, but D, little hint, put this into Y1, and it's a little messy. You have to be really careful when you're up in your exponent. You can get out of your exponent. Put that into Y1 and this in Y2. Okay? And don't forget, you can download a calculator off of Blackboard if you don't have a calculator to do this last problem here. In my Blackboard, it's under textbook and I think other info, or textbook and other tools or something like that. So you can download a graphing calculator, or you can come borrow one during major time. That's it for today's notes. Don't forget, for my class, you also have to do those 2 practice problems from Unit 4 from the end of the notes in Unit 4, number 7 and number 12 from Day 4 notes. But that's just for my class. All right, see you in class.